Okay, so I just learned I can do this thing. We're about to be thinking about solving this equation. I ran out of space on this slide, so I'm going to go ahead and copy it and move over here with it. Oh yeah, that's awesome. Okay. So let's say that we're going to have to write in that we're solving that. Okay. So we're thinking about solving this equation. And when you work on this, like in web work, you'll practice specific examples, but like for different values n, for this one example, we'll just use a generic value n. It means that there's a little bit more symbols hanging around, but you all are very skilled at this type of thing at this point in the semester. So we're going to assume y is equal to the sum from n equals 0. Ooh. N is going to be a bad character to use because n is in our differential equation. We'll use k equals 0 to infinity of c sub k x to the power k. So then that means our y prime is just given by the power rule, starting from k equals 1, because the 0th term will just drop out. It's a constant. C sub k times x to the k minus 1. And y double prime is the sum where we start from 2, go up to infinity, and we'll be looking at c sub k times k minus 1. Oh no, I'm running out of room. But I can just do this. This is shaky. Okay. And my y double prime is that thing. Okay, c sub k times k minus 1. All times x to the k minus 2. So hopefully from solving series solutions, you're kind of familiar with that power rule. Then we just go ahead and plug it into our differential equation. So we're going to have 0 is equal to 1 minus x squared times y double prime. So the sum from k equals 2 to infinity c sub k times k minus 1 times k times x to the k minus 2 minus 2xy prime, the sum from k equals 1 to infinity c sub k times x to the k minus 1 plus n times n plus 1 times y, so the sum from k equals 0 to infinity c sub k x to the k. And then from here, we can go ahead and sort of distribute everything through so that we're looking at sums only. We want to move these x's and whatnot inside the sums we're looking at. So this will give us, let's see, 1 times the sum, k equals 2 to infinity c sub k minus 1, x to the k minus 2, minus the sum from k equals 2 to infinity c sub k minus 1 times k, x to the k minus 2 times x squared is just x to the power k, minus the sum from k equals 1 to infinity of 2 times ck times k times x to the k minus 1 times x is just x to the k again, plus the sum from k equals 0 to infinity of n times n plus 1 times c sub k x to the power k. And just to be clear where all those different terms came from, here's our first term right there. And then we multiplied through by this x squared term to get the second term right here. This middle term, and then I guess I'll do double underline. And then that final term right there. So really the tricky part was the first term. And then we want to make sure that all of the powers x match. We have a whole bunch already at x to the power k. So all we really have to think about is changing this first one to match all the others. So I want it to look like x to the power k, just like everything else. And that means that I'm sort of taking k plus 2, right? K plus 2 minus 2 gives me k. So I'm going to go ahead and everywhere I see a k, just replace it with k plus 2. So c sub k becomes c sub k plus 2. Oh, no, I did not give myself enough room. I'll run out of room over there. Okay, so c sub k becomes c sub k plus 2. K becomes k plus 2. And k minus 1 becomes k minus 1 plus 2 is k plus 1. And then whenever we add on inside the sum, we subtract on the indices. So that's going to mean we start from 0 or 2 before. Now we start from 0. Still go up to infinity. And then everything else stays the same. So you can go ahead and start copying down everything else we didn't change. I'm going to do this because I'm slower than you. And this is an exciting new thing for me. Okay, so that's the only change that happened for us really, is changing that x sub k plus 2 or k minus 2 to x sub k. And now the powers x on every sum are the same. So we can go ahead and think about how we would want to combine all these to a single sum. So let's write it right here, I guess, to give us lots of room for if we need to take care of extra terms. So I'm going to have c sub k plus 2 times k plus 2 times k plus 1 minus c sub k times k minus 1 times k minus 2 c sub k times k plus n times n plus 1 c sub k, all of that being times x to the k. I don't know. It's a good thing this tool exists because I'm really bad at judging how long it'll take to fit space. What did I do? Oh, God. I'm a really bad judge of how much writing I can fit in using this new tool. Sorry, everyone. I know it sucks. Oh, God. Okay. There's our n times n plus 1. No. Times c sub k. Okay. All of that times x to the power k. And so all I've done is I combined all the sums together. If we want to show that, we can say, okay, there was that part, came here. There is this part, came here. There was this part here. And this part finally was right here. So that's just all our different terms combined times that power x to the k. And then if they're inside a single sum, we have to use the highest index to begin at. So I'm going to say, okay, that starts from k equals 2 and goes to infinity. And then what I have to do is take care of all the extra things that weren't sort of captured by starting from k equals 2. So starting over here, we would need k equals 0. So that's going to give us our c sub 2 times 0 plus 2 is 2 times 1 times x to the power 0 is just 1. And then plus the k equals 1 term, so plus c sub 3. 1 plus 2 is 3. 1 plus 1 is 2 times x to the power 1. In the middle, we started from 2, so we don't have to worry. In the third sum, we need to capture our k equals 1 term, so we subtract 2 c sub 1 times x to the power 1. And then from the final term over here, it started at 0, but we've jumped up to 2, so we need to capture our 0 term. That would be plus n times n plus 1 times c sub 0, x to the power 0 is just 1, plus actually what I'm going to do is that's going to have that n times n plus 1 times both terms. So that's going to be c0, and then the k equals 1 term will give us n times n plus 1 times c sub 1 x to the power 1. So there's all of our extra terms right there. And we're going to want to set this all equal to 0. So I'm going to pause here. Next video, we'll start trying to figure out what to do with all of this stuff to solve for our coefficients.